Okay, guys, here we have another problem where it's talking about equivalent expressions or equivalent equations. So, what makes something equivalent is that the value of this equation is the same value as the other equation, right? They're the same. They're the same thing. Okay, but how can they be the same thing when my original looks different than all the rest of them? So, okay, what we've done is like replace variables with numbers. So, but here's a problem. You have y, h, x, g, and k. That's a lot of variables. Okay, that's a lot. So unless you're willing to keep a little legend, a little key with what you assigned y to, what number you assigned h to, what number you assigned x to, what number you assigned g and k, that's too much work and responsibility. So let's just kick it old school and let's just adjust it. Okay, if you notice your answer choices, x is isolated. So because x is isolated, I need to think to myself, all right, if x is isolated, then that means I need to isolate x in my original equation, okay? So I gotta think of inverse operations. So if I think of PEMDAS, I gotta work backwards. So we usually go top bottom, but now we're gonna go bottom up. In other words, I need to think of addition and subtraction. I need to undo addition and subtraction first. Then I need to do multiplication and division, and then the exponents, and then the parentheses. So in this case, I see a division here, right? So the inverse, the opposite of division is multiplication. So I'm going to multiply by k. So times k to this side, I'm going to times k to this side. But here's the thing. If I'm going to multiply by k, that means I have to encase y minus h, this expression in parentheses, and I'm going to keep k out here like that. See? So now what I have left over is x minus g. And so it doesn't even look that bad anymore. I just need to get rid of g. So the inverse of subtracting is adding. So I'm going to add g to both sides. And then I got to do, okay, k y minus h plus g is equal to x. So now that I have this all intact, I gotta go and check, okay, which of these answer choices looks just like the one I did? Remember, we're talking about equivalence, so it can't kind of look like, it has to look exactly like this, okay? So in this case, this is the kicker on this one. It's subtracting g when I should have an addition of g. So even though A looks kind of like my expression, it was not equivalent, it was not exact. B cannot be it, because if you were to distribute k, that means it would be ky minus kh, which that distribution did not happen here. Okay, so this is not even anything close to it. Letter C is correct because it looks just like the one I have. I have k times y minus h plus g. Right? Now let's say it wasn't like that. Okay, let's say when you guys take your STAR tests, instead of this, it would have it distributed. Then it would look like this: ky minus kh plus g. So it could be shown this way. In this problem, the answer was not with a distribution, it was pre-distribution, so with the parentheses and the k outside of it. But if it did have the full-on distribution, we would have to multiply k to y and h. So this piece right here would have been ky minus kh, okay? And it cannot be D again because, first of all, everything's all wrong, right? This should have, if it was distributed, this would have been kh, and also this would have been plus g, right? So the only answer was letter C.